Now, let's take a look at the so-called anthropogenic metabolism. We all know the human metabolism, which you see more or less on the left side of the picture, the prehistoric metabolism. In the prehistoric man consumes about 6 tons of materials per year. Mainly this is air for breathing and food, and maybe some tools, maybe some fur, whatever. While we, in Napoli or in Vienna, it doesn't make a difference, we consume between 80 and 100 tons of materials per year. Most of this material are products such as water and air, and therefore most of our emissions are not wastes like a solid waste, but they are, of course, sewage, wastewater, and gases emissions. The actual wastes are rather small. You see here, only 3 tons come out of this human metabolism. The input is 90, of course 86 here exactly measured in Vienna, and the output of the private household is 3 tons. Per capita, 3 tons of municipal solid waste. Altogether, if you look at just the municipal waste, that means the waste which is produced by consumption activities, it's 0.3 tons only. Most of the waste which is produced in private households is from construction activities. But we don't see that waste, we don't talk about that waste. That's so-called the hidden waste. Now, if you do the balance of these 2 pictures, you will see that the balance doesn't fit. What is missing? Missing is the addition to the stock. So if we look at the right-hand side of the picture, we see that the input is about 3 tons bigger than the output. And these are the 3 tons we accumulate every year in our households on the average. Now this shows us also something about the future waste, and I will talk about that in a minute. And what is really amazing is that we already have accumulated a stock of between 200 and 300 tons per person. So each one of you sitting here at home has a stock of 200 to 300 tons. This is of course your building, the building you live in. And this building of course is a future resource, because in 20 or 40 or 200 years, this building can be used. So this stock is very important. The way we have insulated this building determines the amount of CO2 we need in the winter time to heat the house. Maybe in Napoli this is not very important, but if you go to Scandinavia, it's very important. So this stock determines the future resource consumption as well as the future waste amounts. This has been the private household metabolism. If you now look at the urban metabolism, unfortunately this design is somewhat broken. If you look at the total city metabolism, this includes the private households and service sector and industrial activities in the city of Vienna here. Then you see the input is not 86 tons like before, it's about 200 tons. Because on an urban level, we have more consumption, not just in the private households, but in other activities. And you see again, the main input is water, the main output is water. This is the reason why water pollution control, historically seen, has been much earlier and more important than waste management. And also you see that the second largest output of the city is gases emissions from citizens, from industrial processes, from car traffic, and of course from room heating. And again you see that the solid refuse is only 3 tons. It's comparatively small, and again you see that the stock is big, it's even bigger than in a private household, of course, because all the beautiful churches and buildings and public buildings, they add up to the stock too. If you look at the accumulation, at addition to the accumulation of 4 to 10 tons per year. And if you look at the solid waste of 3 tons, and you look into the future, let's say into 50 years, when the stock turns into waste, that tells you immediately that in the future, we will have much more waste than today. The future waste will double. So such metabolic studies can show you something about the future waste amounts. The stock is really interesting because the stock is a reservoir for the future. It's a resource for the future. And we have modeled the stock for Austria, and we have modeled it for iron. This is the iron household of Austria in million tons. You see the black reservoir in the pedosphere. These are the ores in the ground, which are at present 140 million tons. You see that we consume 2 tons per year, and you also see that in the consumption process, in the entroposphere, we have a stock of 44 million tons. And you see that most iron is imported and some iron is being exported. If you now look into the future, what's happening in the next 100 years, then we see that we are depleting the natural stock. And already in 50 years, we'll have only 40 million tons, and in the year 2100, the stock will be gone. On the other hand, at the same time, we will create a new stock of iron, which is much bigger than the former natural stock. And of course, this future large stock is going to be the valuable resource for the future. That means we are not losing resources, we are just transforming them, transporting them in another place. And waste management means to carefully manage these stocks on a long-term basis. We should not lose these stocks, we should not deteriorate the value by mixing this stock with many other materials, and we should bring in the stock into these constructions, into our infrastructure, in a way that we can make use of it in the future. This is something we teach our young engineers. Design for disposal, design for recycling, green design is certainly one of the main issues if we talk about prevention in the future. So far, I have talked about mass flows of materials, and I've talked about, let's say, beneficial materials. Now let's take a look at some hazardous materials like lead. What you see here is the global consumption of lead over the last 7,000 years, put together by Seton and Patterson in Los Angeles. The increase has been tremendous during this time. It has been an increase of 10 to the 6 to the 7, meaning 1 to 10 million times the increase in lead consumption. You see actually here a peak at 2,000 years ago. Actually, this peak has been taking place on a global scale here in Italy, and it has been the Roman Empire who exploited a lot of lead. You see the global population, and if you divide the global production by the global population, then you find the per capita consumption of lead, and you see that this tremendous increase in lead consumption globally is not due to global population increase. It is due to per capita increase. So we cannot say because of global population increase we have this dramatic increase in many materials. It's more the economical and technical development during the past 200 years which allowed us